The scary part, the most scary part, is that these epigenetic changes, they not necessarily die in one generation. So they can be transmitted to the following generations. And here we refer to some of the work we did with Mike Skinner in my postdoc at Washington State University. And this is in relation to this compound called vinclozolin. So vinclozolin is a fungicide used in agriculture and is an anti-androgenic compound. And this exposure of rodents to this compound was known for a long time to affect early development in mouse in terms of reproductive development. And this before I arrived in the lab of Skinner, by investigating this, they identified that at P60, so 60 days after birth, they checked they counted apoptosis in the testes, and they identified that the rats, the male mouse that have been indirectly exposed through the mom to this compound, okay, so the exposure, and this is important here, the exposure was only 4 days of the mom, okay, 4 developmental days, but crucial developmental days. And after the exposure, the offspring presented higher apoptosis in the testes in the mouse that were exposed in utero to vinclozolin. Now, what is interesting is that following this to the next generations show that this pattern of increased apoptosis in the spermatogenic cells didn't stop in the F1 generation. It went all the way measurable to the F4 generation, to the 4th generation after the exposure. Okay, so I just want to highlight here that the exposure was only one time, was in the F0 mom, but the effect was observed 3 generations after, or 4 generations after here, even without any further exposure. So my role here was answering the question, is this related to the epigenome, but not the epigenome of any cell type, the epigenome of the germ cells? Because if there is a transmission, and they did back crosses here to identify that this was going through the male germline, okay, so then we collected sperm from 3 generations after the exposure and compared the sperm of controls of ancestrally exposed controls versus a lineage that was ancestrally exposed to vinclozolin in utero. And we identified a number of DNA methylation changes in the sperm in promoter regions of the sperm of the mouse. But not only that, we also identified some events of copy number variations. So, and this is interesting because copy number variations are highly also controlled by epigenetic mechanisms. Okay, so there is an effect on the genome of exposure that is not only on the epigenetic side, but it might be on the genetic side as a consequence of this initial epigenetic changes.
Hey, would you like to know how food can be medicine for your genes? Get access to my free webinar using the link in the video description. You will find out how your genes can learn from your lifestyle choices and how you can teach them to unlock their full potential. I hope you enjoy the webinar, and if you do, please make sure to comment and share.